So we are going to be solving square root equations today. They're not too bad. You may have had a practice with some of the simpler ones in past courses. You're so excited. Yay, me too. So let's start with a couple easy ones, then we'll get to something a little bit more challenging. So we have to think about how do you undo a square root? Well, you square it. So if you look at example A, if I square one side, what I do to one side of an equation, I have to do to the other side. So that means I have the square and the square root cancel each other out. So it's just x on the left equals 7 squared is 7 times 7, which is 49. And bam, that's it. Pretty chill. Pretty chill. So let's try that again. With example B, we're doing the same thing. I want to get rid of that radical. So I'm going to square both sides. So on the left, I'm left with x minus 3. And on the right, I'm left with 5 times 5, which is 25. X is not alone yet, so I still have one more step to go. I'm going to add that 3 over to get x equals 28. So not too bad. And I'm not going to do every example on this lesson 2 notes. I'm just going to pick a few because it can be a little repetitive. So hopefully those two are okay. Let's scooch down to like example D. So example D, I'm not just going to undo that square root right away. I still have to follow backwards PEMDAS or SADMEP. So I don't know if you remember me talking about SADMEP when we were solving equations before. But I have to see if there's any piece that I could add or subtract over first, which there is. I'm going to move that 4 over first. I'm going to add 4 to each side. So we have 3 radical x equals 24. Then, is there anything I can divide or multiply by? Yes, there is. There's that 3. So I'm going to divide each side by 3. So we're left with radical x equals 8. And now, finally here, I can undo that square root by squaring each side. So we're left with x equals 8 times 8 is 64. So just make sure you're following backwards PEMDAS when we're solving these. Okay. Let's try another one similar to that. Okay. If I need to slow down, just let me know. Okay. Example E, similar process. I want to see, is there anything I could add or subtract over? That would be, the 2. So I'm going to subtract 2 from each side. So I'm going to have half radical x equals negative 5. And then is there anything I can multiply or divide over? Yes, there is. I can divide by half, which is really the same thing as multiplying by 2. So I have radical x equals negative 10. And now I can finally undo the radical by squaring each side. And notice that I'm putting the parentheses around the whole negative 10 because that means I have negative 10 times negative 10. So I really have x equals 100. So be really careful there. Negative times a negative is a positive. Okay. Doing okay so far? Oop, thought I was going to hiccup. There it is. Okay. So let's scooch down to like example G. So is there any piece I can add or subtract over? Yes, there is. I can subtract over that 7. So I'm left with 2 square root of x plus 5, equals 13 minus 7, which is 6. Then I ask myself, is there anything I can divide or multiply by? You can divide each side by 2. So we have radical x plus 5 equals 3. You think this is easy, Maya? Cool. I don't think it's too bad. Now from here, I can't subtract that 5 over because it's locked in under that radical. So here, I can square each side to unlock what's underneath the radical. So I'm left with x plus 5 equals 3 times 3 is 9. And now I can subtract over 5 to get x equals 4. So nothing too shabby there. Okay. So let's scooch down. I'm going to go to the second page of your notes now, and we're going to check for something called an extraneous root. So with all these answers, you want to make sure that when you put the answer you got under the radical, are you going to get something that's a real answer? So what I mean by that is, I'll just scooch back up to the top. If I put 40, can I have radical 49? Yes, I can. I'm not going to get anything imaginary. So we want to make sure, like if I put 28 under for x, so 28 minus 3, I still have a positive number. That is allowed. So with all of these, the answer we got would give us real answers. What we're going to do down here is sometimes you might get an answer that'll give you a negative under the radical. And as we saw last week, that would be an imaginary number. So we do not want that. So we are checking for something called extraneous roots. So we're still going to do the same pretty much process, but with this one, you'll see it's a little bit more in depth because we have variables on both sides. So the goal is to always get the x alone. So if I'm looking at the left, I have everything is under the radical, so I'm going to square that since there's nothing I can add or subtract away from it. So I'm going to square each side. So on the left, I'm left with 2x minus 3. But over here, if I square that quantity, that means there's two of them now. I have an x minus 3 times an x minus 3. So with this one, there's a little bit more simplifying that we're going to have to do before I can just solve to get my x alone. Now, if we were to double distribute this, when the dust settles, well, the left is still going to be 2x minus 3. I'll just drop that puppy down. I'm going to get x squared minus 3x plus 9, which means we really have x squared minus 6x plus 9. Now, anytime you see a squared and you see an x to the first power, that means we're going to have to get all the x's to one side, and we're probably going to have to factor this. So here, I want to make sure I'm keeping that x squared positive. Otherwise, your heart's going to be a little bit sad. So that means I'm going to subtract over 2x, and I'm going to add 3. So minus 2x and add 3. So I'm left with 0 equals x squared minus 8x plus 12. So let me write myself a little note here. So keep x squared positive. Otherwise, it's going to be ugly to factor. You don't want to do that. All right. So from here, I'm going to double bubble this. X goes in my first spot. We are multiplying to get a positive, but combining to get a negative. So that means both my signs in here are going to be negative. And what multiplies to give us 12, but combines to give us 8, that would be a 6 and a 2. So from here, we can use our zero product property. So I can do x minus 6 equals 0. And x minus 2 equals 0. So I can either get x equals 6 or x equals 2. Now what we want to do is plug both of these back into the original to see, do we get a real answer or are we going to get something imaginary? So let's do like a little check here. So I'm going to check for x equals 6 first. I'm just going to use the radical side because that's what I really care about. Am I going to get something that's no bueno? So it's going to be 2 times 6 minus 3. So radical 12 minus 3, radical 9. That is something that can be evaluated. So x equals 6 is good. Oop, that's a bad circle. So let me try x equals 2. So let's check x equals 2. So I'm going to get 2 times 2 minus 3. I get 4 minus 3, which is 1, so that is allowed as well. Okay. So you want to make sure that you're not getting anything that's going to sketch you out. Okay. So let's practice solving another one. So this is a good example because we want to make sure we're still following SADMAP. Always, always, always. The last one, there wasn't anything to add or subtract away from the radical, but this one there is. So over here, I'm going to start by adding 2 first. Now, 2x and 2 cannot be combined. So I'm going to have 2x plus 2, oops, a little messy there, equals radical x plus 6. And now, since there's nothing to add or subtract or multiply, divide away from that radical, won't let me change the color. Come on. Oh, my pen's frozen. Yay, technology. Did my pen die? Oh, there we go. Brace for squiggles. Oh, didn't draw. Cool. So I'm going to square each side. That's a sad little 2. So remember, when I square a binomial or any polynomial, that means there's 2 of them now. So I have 2x plus 2 times 2x plus 2 equals x plus 6. So now, when I double distribute that out, when the dust settles, I'm going to get 4x squared plus 8x plus 4 equals x plus 6. If you want to show that middle step where you're double distributing, you can. I'm not going to. And then, like before, I want to make sure I'm always keeping that x squared term positive. Otherwise, it's not as nice to factor. So here we're going to subtract x, and we're going to subtract 6. So we get 4x squared plus 7x minus 2 equals 0. Now, when you get to one like this where you have to factor, remember, you may have to try it a couple times because it's kind of like a guess and check. So your options for going in the double bubble could be 4x and x, or it could be 2x and 2x. So again, this might take you a couple times to get the factoring right, and that's okay. As long as you have a little piece of scrap paper by your side, all is well in the world. So the only way to multiply to get 2 is 2 and 1, and we're multiplying to get a negative, which means my signs have to be different. So let's just try like minus plus. I'm trying to get a 7 in the middle, so I'm going to say my 2 is going to go over here. So when I multiply these, my 4 and my 2 get multiplied together. So that would be 8, and then negative 1 times x would be 7. So I'll just show you what my thought process is there. So this is 8x. This is negative 1x, and that indeed will give you a positive 7x. Remember, that's the little shortcut to simplify. I'm just going to delete that, though, because now I can drop down my table. So I get 4x minus 1 equals 0, x plus 2 equals 0. Over on the left, we can add 1, and then divide by 4. And then over here, we're going to subtract 2. So x is negative 2. So again, then you'll want to check to see if any of those are extraneous. But I just want to make sure you're good with the solving portion of it. Let's see, are there any others I want to do? Ooh, yes, I'm going to do examples E and F, and then we'll call it a day. Okay. All right, so example E, again, I'm looking at the big main radical. Is there anything I could add or subtract over? Not yet, because I'm locked in with a radical. So I'm going to go right away into squaring both sides. Now this squared is only going to cancel out the big main radical that you're seeing. So we still have 2 minus radical x, so the stuff that's left under, and then over here the square and the radical cancel each other out. From here, I got to see, is there anything that I could subtract or add away from that radical x? There is. It's a minus 2, so I'm going to have negative radical x equals x minus 2. I'm just subtracting that over. I'll show that if you want. Minus 2, minus 2. Okay. And then we're still up with this negative in front of the radical, so I'm going to divide each side by that negative, really like a negative 1. So that's going to change all the pieces. That's going to be radical x equals negative x. Oops, that's not an x. Negative x, plus 2. And now from here, I'm still left with a radical, so I'm going to square both sides. So on the left, I'm just left with x, but over here, remember that quantity is going to be twice, so I have negative x plus 2 times negative x plus 2. So then we're going to double distribute. And when the dust settles, when we do that, we get x equals x squared minus 4x plus 4. And we want to keep that x squared positive, so I'm going to subtract over the x. So we get 0 equals x squared minus 5x plus 4. And then we can factor x and x. We're multiplying to get a positive, but combining to get a negative. So both my signs are going to be negative, and I've got a 4 and a 1 to give us 5. From there, we can drop down our t-chart. So I have x minus 4 equals 0, and x minus 1 equals 0. So therefore, I could have 4, or I could have positive 1. And again, you got to check for extraneous roots, but I'm just showing you how to solve to make sure all is good in the hood. Okay? So that one was a little bit beastly to solve. But remember, you got to keep that x squared positive or your heart's going to be sad. Am I good so far? Let me do one more example. All right. So, excuse me, boy. What were we on? Okay, so here again, we're checking, we're doing our SAD map. So is there anything that we could add or subtract away from the x? So, or excuse me, from the x, from the radical. So yes, there is, it's an x. So I'm going to subtract that x over. Again, 5 and x are not like terms. So on the left, I'm still left with this radical. But over here, I'm left with 5 minus x. And then from here, I'm allowed to square this to undo my radical. So I'm left with 4x plus 1 on the left and 5 minus x. Oops, my pen froze a little bit. 5 minus x. Or if you wrote it as negative x plus 5, that's okay too. Either is valid. Oh, thank you, Maya. So over here on the right, we're going to double distribute that out. When the dust settles, we get 25 minus 10x plus x squared. And again, you can show that double distributing step. I'm just not. We need to get everything to the same side, and I'm going to write this in standard form as well. So we need to subtract 4x from each side and subtract 1. Come on, pen. We're almost done. So I get 0 equals, and again, I'm writing this back in standard form. So x squared minus 14x plus 24 is what I'm left with. Then I can a double bubble. And we're multiplying to get a positive, but combining to get a negative. So both those signs are going to be minus. And then I got to think what multiplies to give me 24, but will combine to give me 14. Well, that's going to be a 12 and a 2. So x minus 12 equals 0. X minus 2 equals 0. So x could be 12, or it could be 2. And again, excuse me, check for your extraneous roots. And you can really just plug all that in your calculator and see which one is going to give you a valid answer or not. So, any questions? Are you feeling okay? Do you want to know what the homework is? Okay, so extraneous means two things. It could mean that you get something invalid under the radical, or it means when you go back to do the check and you plug it in, you get something like 7 equals 2, and that doesn't work. So make sure you're checking both answers, and that's it. So your homework tonight, there are 2 practices in Khan Academy. If you need any help, you know my office hours are 10 to 11 Monday through Thursday, and then for Algebra 2, you even get your own little special spot on Thursdays from 1 to 2. So let me know. And I will be live again on Wednesday at 12:15. So have a fabulous day.